Greetings, welcome to day 87 of projectDIG. Thank you for joining. projectDIG is a 2D multiplayer automation survival sandbox game that I am designing entirely here on Twitch and uploading all the VODs to YouTube. We're doing particle system stuff again today, hopefully getting some rendering happening. Trying to make things happen. Again, it's probably going to be a short stream. That just seems to be my life now. So let's go ahead and get started. So, yeah, I don't know. Particles, that's what we're doing. You know, fancy things like hit effects or smoke, fire from torches. Things along those lines is what particles are often used for. So we have a lot of this down. I think we are just needing to implement some sort of draw here. Hey Dallas, what's up? Hello. So yeah, we need to draw the particles. I think it's going to be pretty similar to what we have over in our render system for drawing the particles. And I wonder if we could almost like refactor this and just pull it out or something. Because what we need is pretty much this here. We need it like exactly, huh? Trying to think how it might be different. I guess, yeah, that's the difference is that, what is this? This is sprites. We don't technically need it to be sprites because I guess it could be almost like vertices, right? Because they all have the same texture for text data. It's kind of a mixture of the two. So, on earlier than usual, yeah, well, yeah, it's just, we have a babysitter that comes over at 8:30, so, and it's 8:30 right now. So, yeah, sometimes I'm still like trying to wrap things up in the morning, or like I have a chiropractor appointment usually after our sitter comes, but today I don't, and so I was able to actually start on time. On time. Yeah. How's it going, guys? What's up? Hope your week is progressing well. So this is all the rendering data. So basically what we need to do is we need to render a lot of particles on screen, and we do need to support some things that sprites support, such as changing the color. Well, I guess vertices change color, right? But they don't support rotation. Yeah. Our sprites support rotation. Excuse me. So we have that here. So this is kind of more like our sprites, but we're gonna replace it some. Yeah, I don't know. I wish that I could like confidently say that this was going to be the same. Let's just see what this looks like. I really need to come up with a better way to do this though. I did this for render, or what was it called again? The lighting. Something similar. This right here. It's going to be kind of like this. This line needs to be changed to here. We need an identity matrix, which I believe I just set up here. Here's our view Z. I need to come up with a better way for this. I hate doing this. Just like, I don't know how to nicely refactor this code without having it lose a lot of performance. I don't know, maybe it's like I can't really refactor all of this, but I can refactor like this code or something. Like there's this chunk of code here that I do repeatedly, which is like, what does it do? Maybe the trick would be not putting in a function, but putting in like some class. Maybe that's what I need to do. But this basically just checks to see if our vertex buffers have ran out of space, our vertex buffer or index buffer, and create new buffers if we need to. Submit the current one we have, create new ones. Okay. So actually, now that I think about this, I realize that I need to put it in an outer loop after all. Like, kind of like what I have here. Right? There's one thing that's a little inefficient about this. Ugh. So what we need to do is iterate through all, not the sprites, but the emitters. Right? So, like we have our emitter components down here. And I guess we need the transform component too. Something more like that, I guess. Right? Does the emitter component have... I guess it's... From the emitter component, we get the texture, or we get the What is it called? Oh, we're gonna have different channels. That's right. I kind of forgot about that. Now I'm starting to wonder if this is actually more efficient. So the thing that's happening here is that I kind of forgot about the channels. Maybe what we should do is like the simpler solution for nah. So we have different emitters. Each emitter is composed of channels, and each channel is composed of a bunch of particles. And so that means that every single channel can have different properties assigned to it, like what's the I guess a lot of them, they kind of don't matter. The biggest one is going to be, we can go here. It's going to be the texture. Wait, where's the texture set? We have the channel. Okay, here it goes. The channel itself, emitter channel. So the emitter channel has the texture. And a cooler candy popper, welcome. And so because every single channel can have a different texture, that makes things a little awkward because, you know, we want to be grouping up all of our rendering by texture. And so, so like, I don't know if this is going to completely work out. Yeah, this kind of doesn't work too well, huh? Okay, so imagine that we have, let's say, torches on the screen. We have 20 torches, and the torches have 2 channels. The channel is kind of like a layer. So we have one layer that's in the back, and that's smoke. And so smoke is coming up behind everything. And then in front of it, we have a like fire particle. And the smoke like lives a little bit longer, and so it rises up behind it. And you know, that probably look pretty good. The smoke could have one texture that's using, and the fire is using some other texture. If we are going through all of our particles and rendering them by emitter and then by channel, what would end up happening is that we're going to be breaking those up a lot. Like, let's say we could have, you know, 10,000 vertices that we're rendering for the smoke, but actually each emitter channel, smoke channel only has, 20 or 50 or whatever. And so we do smoke, and then we switch to fire because they're on different textures. Smoke, fire, smoke, fire, smoke, fire. And so instead of doing like 2 draw calls to our render backend, we're doing like 40 because we keep flip-flopping between the two. So this actually kind of sucks. And that's one of the nice things about what I do for this. Maybe what I need to do is like submit the emitters, or I mean, I guess I could do it in here. Basically go through all the emitters and group up the channels by the texture, or that's right, it would be by the program, and then render them that way. That could work. So it could be like this. I'm just gonna put that there so it stays. This might work, now that I think about it. So that's what we do with our render system right now, and that's partly why it's such a mess. Where are we? So we need to iterate through. I guess we want like all of that information. Most of it. We don't need this position. We don't need the keep alive. So what we do is we get the emitter data. We iterate through all the channels in the emitter data. We get the channel. The channel contains the render texture, which we definitely need. We might not need this channel state itself. Maybe not. We might actually want to just get the pointer for this. Or something. That's currently what contains all of our particles. So oh, that's true. One thing that we might actually need to add to this is our shader. In the emitter channel. And then what we can do is the same thing that we've done in our render system many times. I think we even have a function to get it now. Here's a get program, program handle, get basic program. That's not quite what I'm looking for. Okay, so I do kind of want the program handle, not the... Yeah. That's our shader program. Okay, where do I have that at? Group UID. I guess I just do it here. Okay, I thought I had it elsewhere, but this is it. So we get the program. Maybe we need to do something more like this. Where we have our two shaders. We have our vertex shader and fragment shader. Which I think... Yeah, it's a resource handle. Okay, that's what we do in other places. We should do that too. Resource handle, vertex shader, resource handle, fragment shader. So from that, we can get all of this information and do something similar to this. So let's go to particle. Okay, so with this, we can get the render, get program. We have our channel vertex shader and channel fragment shader, which gives us the program, our shader program. If it's invalid, then we can just continue to the next one. I don't know why that would be invalid, but just in case, we skip it. We then calculate the group ID. Channel, whoops, texture resource. Oh, okay, I need to do texture resource. Channel, texture, oh wait, I need, resource, get texture. Okay. So that's our texture resource. We'll get the handle. So this gives us a unique ID based off of the resource, the texture resource, and the program. And that's what we need in order to be able to render them together. If the group UID is the same, that means that it can be batched together and it's optimized. And so what we can do is say, hey, all of the smoke, that's all going to be together. All of the fire, that's all going to be together. If they're on the same texture and they use the same shader, hey, guess what? They can all be together. One big happy family. Okay, so now let's go ahead and add in resource.h for this stuff. Oh, that returns const ref. Okay, I guess I should probably do that. So that now means that we need to kind of add this somewhere, right? This is where we need to have something. One thing we could do with this emitter channel state is we could store a pointer to this. Since it's only going to be in this function, I feel like that's okay. You know, just like say, hey, instead of having a reference, we could get the pointer to the emitter channel and store that. And so that's has all of our particles, and I think that's all we really need is our particles, right? Maybe what we could do is maybe we can make this be more generic. Let's do this. Let's put in a simple little struct class or struct here, which is particle data particle render. Oh no. And so what we want is a particle pointer. And then I feel weird doing this because this is not like how I typically do things. How many particles? And then we could just increment this pointer for count amount. And the nice thing about this is, and I guess, do we need the program? Technically, we can pull it out from here, or the program and the texture. Technically, we could put in here the texture resource. Right? Or what is it called? It's called the BGFX texture handle. And then we could also get the program handle in here. That's what we're going to be throwing into BGFX. So with our particle render data, we can now say that we have something kind of like our vertex data. Or no, vertices. Where do we set that up? I think we set it up here. Yes, set deleted keys. Keys are BGFX handles. Deleted. I need the empty. So this is going to be, I guess we'll start with this. The hash map of particle render data. Maybe I'll just call it particle data. And then we're going to need, I think, the vertex, at least one of these. Whoops. Maybe both. I know I need to change the name. I'll do that once I copy these over. Okay, so we'll rename this to particles. So that's all of the particles that we're going to need to render. And so once we get this all set up, what we can do is, well, I guess we need one more thing in here. which we can grab from in here. So we say we try to find it. If we did find it, then we want to add it in. Oh, that actually doesn't quite work, huh? Dang it. I should have realized that. Yeah. We'll have to think of a different way to do that. So, I just realized that let's say that we do have an entry of this particle data in here. What we really need, I guess, is like a vector of this stuff. Is that good? I guess that's what we probably do here. Yeah, vertices. Something like that. I don't even know if we really need a different struct for that. So maybe something along those lines. Not crazy about that. But what this will allow us to do now is add in new particles into this. So we say, let's see here. So first we get the channel. From the channel, we make sure we have a valid program. That's our shader program. If it's invalid, then we continue to the next channel. Then we get the texture resource. We calculate the group UID from the texture resource and the program handles. We then use that to look up the channel or the group UID. I think we need this regardless. We say if we did find it, so it did not hit the end, then what we want to do is just push this back onto the list, right? And I think that's all we need to do is say particles data. That's an iterator. Wait, what am I doing? What am I doing? Do it like this. Particles. Push back. Actually, we can just in place. Place back. Going to be this channel state pointer. So we just want to say, hey, this is the channel state, particles, and 0. This is densely packed. And channel state count. And I think we need some little constructor for this. Okay, and so that we are just adding it onto the list. If we did not find it, then what we need to do is create a new program data, particle data for this. Just like what we do over in here. We set it up. So this is the same. Text of resource width and height. I wonder why I pulled that out. Got that a little wrong. Okay, there we go. So now we have our particles. Particle data we pull from this. This creates a new particle data. We get the reference to it, and then we're setting it up. We need to, lastly, let's do the same thing. Actually, we can just copy this line, right? That's just gonna be data. We don't have an iterator for this. Is the actual thing now, not an iterator. Okay. So that's it for setting that up. So now we have our particles where it's all set up based off of, I guess we don't need the transform component at all, huh? Okay, well that makes this easier. And we technically don't even need the entity, so we can just do that. Nice, that definitely optimizes things. Why not reuse the particle data iterator? Because it's pointing to the end, right? You're talking about right here, this particles data? If you find it, we did, so how this is working is we set up this particle. So this is an iterator. So we look for it. If we find it. So this is if we find it. So we're not at the end. We then use it to. No need to look up again. But in this case, it hit the end, so it's an invalid iterator. So yeah, this case, the if case is we found the particle, like we found this group. So we're basically, we're trying to group things up by their texture and handle and program handle. That's the group UID. And so if they're in the same group or they have the same group UID, that means they can be batched together, making it so we can render things better. So yeah, if they're in the same group, so we found it, then we just say, hey, add this to the list of particles that we want to render inside of that group. If we did not find that group, that means this is an entirely new group, and so our particles data is, particles end, so it's an invalid iterator, so we need to add in a new... No, you're fine, you're fine. If I'm not explaining this well enough, then I'll try to explain it better. I need my coffee. We all do, man. Here's mine. They're good. Encrypted feelings. Now, I like it whenever someone challenges me because, hey, you know what? I'm wrong very often, and even whenever I might be right, still doesn't hurt to kind of go over things and make sure that others understand and also that I fully understand what's going on. So I think this does make sense. So now we have this hash map of particle data that contains information or texture handle and program handle for us to be able to render stuff, as well as, oh, that's why I saved that. That's right. I think we do need to have the width and height be stored in here as well. Like what I did here, because we have that from the texture resource itself. So that's an int32. So I think we do want to do this. So that, because we need to, for the UV, alright, yeah, the UV, the texture coordinates within the texture for, you know, so let's say we have this huge, sprite atlas, and we're wanting to get specific, you know, area within that texture. We need to be able to calculate the UV, which is taking the X and Y coordinates of the, you know, the texture rect and dividing it by the width and height. I do wonder if it would probably be a lot more efficient if we did that outside of this. Maybe that's something I should really look at doing, is like whenever we set the texture rect, which I don't even think we have a texture rect right now, but whenever we do set the texture rect, maybe it would be better if I just divided by the width and height there. So the coordinates that we do have in here, the texture rect, that's actually just straight up the UV. But anyways, right now we don't have that. Maybe that's a change we can make in the future. So let's go ahead and say that we have the width and height here, so we can go ahead and divide by it. I think we need to include that just coming from here. Okay, so that will give us like this MTX identity as well as a few other things that we needed. Texture sampler. The texture, I don't know what this is. We probably use that in here though. Texture. Oh, this is not using textures. Texture sampler. We might actually just have under. Oh, maybe I don't expose that, or I don't remember exactly what that is. I'm trying to think. I guess I might not use that anywhere else right now. So uniform handle would definitely be easy to expose. Create uniform. Okay, I guess we'll just expose it like what we did with the basic program. Uniform handle get texture sampler. Oh. Forgot about that. We don't actually have that shared, or yeah. Okay. So we can just set that in here as well. BGFX, uniform handle. Sampler. I don't know. I guess this is like, nah, let's just put it there. We don't need to store it. Whatever. Oops. Okay, so that's all good. We're going to need to change that stuff though. So yeah, this is going to now need to be iterating through every single program data, particle data. Because every single particle data needs to be batched together. You know, that's what we're doing, is we're trying to batch it. So we'll say for particle data, I think particles. I don't know what I want to do with that yet. Particles. I don't call it. Oh, I do call it m_particles. I should change that. That's right. Here, let's do this. Group UID particle data. There we go. And let's rename this to just be particles. Okay, so now this is what is that called again? Structured binding? Yeah, structured binding. So we get from this hash map the group UID and the particle data, and then what we need to do is we need to set up the number of vertices and indices based off of how many particles we have in that. And I guess maybe what would make sense here is to do something like this, like count it up while we are total particles while we are adding the particles on. I think that would make sense. Because then that would greatly simplify this. We could just say, hey, this is the total number of particles. Oh, whoops. Particle data. Particle data. I think I might just say total. That's fine. So that's how many total particles that we have. Total, let's rename it particle count. Let's just do that, particle count. So then what we'll do here is we just need to say, hey, this is going to be increased by this count. And then down here, this is going to be set. This is data, particle count is set to the count. Yeah, that's fine. Total particles, particle count. So we're just trying to calculate how many vertices we need, how many indices we need, and that's going to be the particle count times 4 or times 6, respectively. And then from here, we can get the texture. That's just going to be the particle data. That's the texture resource. Oh, why do I need the texture resource? Oh, I guess we don't. Never mind. Because we have instead the particle data width and height here. Texture resource dot handle. That's just going to be our texture handle. Texture sampler. Where are we setting the program? Is this supposed to be here? I think this is. Where are we using? Where's the program at? Yeah, that's right. Vertex data.program. Right. Okay, that's what I was thinking. So this needs to be particle data. program handle. Same with this down here. This needs to be changed to particle data texture handle. So what we do here, this is one thing I really want to try to figure out how to nicely refactor, because we've done something very similar to this in like probably like 8 places now. Which is, so like the general flow for this is we have all of these particles that are being batched together. So we want to batch all the particles together, and then so we get this vertex buffer and index buffer, and then we go through all of the particles, and we're trying to you know, draw them. We're trying to populate the vertex data and the index data properly. And then if we run out of vertex, like if either of our buffers run out of space, then what we need to do, because you know, maybe we say, hey, we want 10,000, but we only have 5,000 available, so we might have to like split this into 2, draw submits. So what we do if we run out of space is we go ahead and submit it, and then we we once again get a vertex buffer and transient buffer. Sorry, a transient vertex buffer and transient index buffer, and I don't know if that's what we probably do need those transient and yeah, I think we want a transient buffer. So that's if we run out of space. And then what we are actually doing here is we are trying to, you know, populate this data. So that's what we do here. This could probably be improved as well. Yeah, I'm sure that this could be improved. And then lastly, once we finish writing them all out, we go ahead and, you know, do the final submit. Yeah, VA is pretty good. Visual Assist, I like it. Okay, so this for loop obviously needs to change dramatically. What we're going to need to do is actually iterate through. This is, I guess what we need to do is iterate through all of the, yeah, this is kind of weird. We need like a, because they're not all together. If it was all contiguous, it would be easier. So we kind of need 2 for loops here. We need 1 for loop for this. So is this going to be like for const? Yeah, particles. The problem is, oh, I guess we don't call. Oh, we have this called particles. Maybe we'll rename this to like particles. Batched particles or something like that. So then we could call this particles out of R, and so this is going to be our particle data particles. And then inside of that loop, we need another for loop, which is actually going to be the count. Which is, we don't want it to be const. I guess I don't actually have this be size T. What's our channel count? What is that? Is that, that's an N32. Okay, I guess I'll just have this be an N32. I equals 0, I is less than the particles count, increment I, and gonna need to, oh wait. Yeah. That's right. This project tree you have is so weird. It's almost like it has a billion files within only 2 folders. I have more folders than just 2. I have, yeah, it's, I don't know. I'll probably end up, I don't know if it needs to be split up more. And Guzman, what's up? I think it's okay. Why is it weird? Like, how would you do it differently? Okay, so now what we want to do is we need to get this particle pointer, right? This is the current particle, which is going to be particles data plus I. And so this is our initial pointer. And then we just add I to it, up to count. And that should give us a valid particle. We update this. So this is going to be particle count. This is kind of weird. Sprite texture rect. That's just what this is, right? The width and height. Wait, what's this for? This width and height? Oh, it's right there. Oh, that's the texture rect. Oh, okay. Yeah, that's, I think our problem is that right now we don't actually have this given a texture rect. So I guess we need to do that. Like for our sprites, is that? I'm a proponent of the few folder org. Yeah, I think there's, you know, like everything, there's a middle ground. You want enough folders where like you don't have it all in one big, you know, if you only have one folder, then it's kind of hard to find things. It can be harder to find things. If you have lots of folders, then it can be just as hard to find things, or you have to spend a lot of time and you know exactly where it's at, but you have to go, you know, 3 folders down or whatever. So I definitely don't really like nested folders. I don't know, I group things up whenever I think it makes sense, or whenever I have a lot of something to group up. If it's only like 2 random things, then I don't really know where it should go. I could see some of this stuff going in like resource. Maybe that makes sense to go in utility, or I don't know. Like I'm not sure. So it looks like we use, it's typically pixel rect is our texture rect. So we need that. So that's going to be our particle. Oh wait. Oh, I guess I need to. Is that going in the emitter channel? That's actually a really good question. think I need to put it on the particle itself, huh? Because every single particle could have, like, we might have a big sprite atlas which has lots of possible different, like, particles on it. And so every single particle could have a different texture rect. What's your opinion on GSL span? I don't know what that is, so I don't have an opinion. What do you think of WADs versus image sound files? Like WADs. I don't know what a WAD is. WADS. If you guys want to enlighten me, then maybe I might know what it is, but I just am not familiar with the name. So yeah, I actually think that we want to put the texture rect up here inside of the particle. After all. So do this. One files where's all the data is a binary file with all the game file. Oh, okay. I think that they can be good. So like Blizzard has their, no, I'm forgetting the name. What is it called again? MPQ, right? MPQ file. I think it's fine. I actually started working on a WAD. I don't know if that's how you pronounce it. WAD for Korea, and try to get that working, but I had some challenges with it. We as in Andrew and I will probably do that for projectDIG or whatever. I think it's good. Like, I think it's better than having lots of small files. Because, like, maybe having them be in larger, like, you could split them up. But I think having fewer files is generally a lot better than having one big file. Yeah. Yeah, I think I got what you're going for. The problem with lots of smaller files is that really it boils down to there's an overhead whenever you are accessing a file. I think that overhead is probably getting smaller as our hard drives are getting faster and better, whatever. So maybe it's not going to matter as much. I'm not sure about that. But yeah, if you compact it all into one file, then you only have to kind of read that one file. I mean, you can like load it up and have some table of contents essentially that's telling you, the program, like, hey, here's where you need this stuff. So you can only read the beginning of the file, and then whenever you actually need to, you keep the handle open, and whenever you need to read other parts of the file, you can. You have the table of contents. You're like, oh, it's offset by 24,000 or whatever, and go there and read for 7,000 bytes or something. Yeah. If you want to allow modding, having separate files is a good thing, I think. Yeah, so what we'll probably end up doing, just not just for modding, but also for development purposes, is, you don't want to have to repack everything every single time you're going to be testing stuff. So what I'll end up doing for projectDIG is supporting both, where if the individual file is where, like in the subfolder, like, oh, it's in data something file, then read that. Otherwise, go to, the big blob of data and read the file from there instead. So try to support both using the individual file as like the preferred file, because then you can easily change that while you're testing things. That's what I think. Your particle struct is like a span, pointer plus a length. Okay, I think I have heard of that actually. Spans. Yeah. Oh, it was added in C++20. T element type, the extent. That's nice. No, I like it. I don't think we really have access to this, but I think that's cool. T extent, yeah. Makes sense. So like if we wanted this, instead of having to do this here, well, the thing is that it'd be different for every single one, right? I guess what we could do is once we hit the end, like right now, like this count technically is not really needed, and we could probably simplify this if we really wanted to by like, we know at the moment at least that every single group of particles is 100. Like every single channel is allotted 100 particles, and I am going to change this data structure some and move this around in the future, but what we could do is to say, okay, use 100, and then whenever, and look at something inside of the particles to determine what one is the end or whatever. There's one in GSL. Okay. That's why you said the GSL part. Gotcha. Span is const. Yeah, I mean, this is a better version of what I have, right? Like, this would support iterators, so that way, like, this is much better than what I'm doing. And maybe I'll make a note. Right now we can discontinue, but I'll make a note saying, hey, maybe we should use a span here. Honestly, a lot of this is probably going to change. Well, not a lot, but like this part. How we're storing these particles, it's going to probably change whenever we change where the particle is actually being stored. Because right now, it's being stored on the component, but what I'd prefer to do is have it so that all components share, or not all component, the particles are shared between all of the components. And so we have like, 10,000 or 20,000 different particles split up by 100 chunks, or maybe 200, whatever. And then we assign the emitter just some offset. We say, hey, your particles are at 27. And so we know that's 27 times 100. And we have 100 particles or something like that. And so this would just be like another int or whatever. I think that would be much better. And then we could just like change it around. But yeah. And so maybe then instead of having to do it like this, or even having this stored, the particle data, maybe we just have like the offset. And then we would know like, hey, instead of having a pointer here, we know we can calculate the actual particle we need by looking it up in this huge array of particles, and this is going to be the offset offset plus I. Are you making instances for every particle? Instances. Not in this drawing. I mean, we have an instance for all the particles, but only one instance. I mean, and we need to have that data stored somewhere. So yeah, like maybe I'll make a note here. Could use a span here. This might depending on how we end up storing all particles. Yeah. Okay. So let's continue. So yeah, we have our particle pointer. The origin. Translate by the origin. I think it's a good question. I think we just want to have it be centered, right? I think typically we'll just want to have it be centered. The thing is that kind of sucks. That's going to be the text direct. I guess we have the center, right? I can just get that. That's a pixel vector. I probably want to change that as well. Okay, so then this is particle position. We get the X and Y. Particle scale. It's uniform, so it's a scale. Like we don't support scaling separately on the two axes. And then this is the particle 2 radian. Oh, we already have a 2 radian. Cool. That the angle, I guess. What are we doing here? Direction. Okay, so this is SRT, scale, rotate, translate. And so we just we're calculating the final model for all of this. Vertices. Now, this is one thing I'm not crazy about, like this whole thing here. I think we could do a much better job, like instead of like what I'm doing is I'm actually getting this position, color, texture, vertex, or I'm like creating this, and then I set it up here, and then I copy over that data into our vertex buffer, which is just kind of it's kind of gross. So that's something I want to fix up. We'll do that later though, because I want to see if we can just like get something, working. think this is pretty good. I might be wrong. I like top left origins usually. Yeah, I do too, but I think that in this case, we might want to have it be mostly for, yeah, for the particles. I think we typically want it to be separate, but what we probably end up doing is having this be like pre-calculated or something. So we don't have to recalculate it every single time we're rendering it, because the text direct, like, that's not going to change very often. Or like ever. And I do think whenever we do this SRT, well, specifically the scale and rotation, we are wanting to have it be rotated in the, or yeah, I guess we translate it by the origin, that's right, and then we do the SRT. So we scale it at the origin position, we rotate it at the origin position, and then we translate it to the final position based off of that. Or, yeah, I think that's right. It didn't like me. Wait, what begin function? Auto cannot be used before it is defined. What is it trying to do here? Component pool. Cannot be used before it is defined. I'm missing something here. It doesn't like this. Here I do auto ref. That should be fine. And that's just giving me, it should be an emitter component. Oh, I'm using auto here. I see. Whoops. Oh, right. I know what the problem is. It's that there's this weird thing. I need to fix this component pool. I think it's here. Like, I need to include. Is it the component pool? Or it might be component pool.hpp. Yeah, it's that I need to include the component pool.hpp if I use the query for a single component. And the reason for that is that it ends up going to our query.h, and down in here, like most of the time we're not using the component pool, so it's okay. But in this case, we iterate through the component pool directly, which is much more efficient. And we can only do that whenever we're iterating over a single component. Yeah. How long would you say your compile time is now? Probably like 2 minutes. Not sure. Probably longer than I want. Hey, Aurelagi. Just got another notification on game, and I join in to say hi. I love your game. Hey, thanks. Thanks for joining. Are people getting notifications if I'm live here? Well, I'm curious. Let's see. Okay, so I think we have this all set up. One thing we do need to do is actually add in particles somewhere. Set that up, but I think that's it. Let's see. I'm just curious if notifications are popping up in Korea that I'm streaming or not. It technically shouldn't be, but hey, Stevoid, how's it going? It doesn't look like it is. That's good. Yeah, I have it set up like this is one really cool feature in Korea that I want to do for projectDIG as well. Is that I'll notify people that I am live, and I might actually even make it so like maybe I do something on the main menu as well. But yeah, just let people know, hey, I'm streaming, and so like there's a little notification that pops up down in the bottom right corner. It says like watch the development stream live, and it will only display that if Korea is in the title or the category I'm playing is Korea. At least that's what it should be doing. But yeah, it'd be cool to have something over here as well. Like maybe whenever I'm live, there's like a big little like thing over here. I don't know, whatever. Something that's like, hey, it's live. Come watch. I think that'd be cool. That'd be for like projectDIG, future games. I like to just do a better job with stuff like that. I think Clay has done a great job with kind of like letting people know that type of stuff. Like also maybe having something that tells people when they should expect the next update. I think that's really cool. Something Clay has done for I think pretty much all of their games. Okay. So yeah, it's compiling right now. One thing we need to do is go over to our game file, and we need to make it so that whenever we do something, it create particles. So I was thinking we could just add into here like an else if. I need to do, something better than this, but let's just say P. Is that a thing? Or is it like key P or I don't know. It's lowercase p, I see. For particle. So we press P, we want to create particles at our current position. That's what we want to do. 2 minutes for compile. Wow, it's good. I have only 1.5k lines. Yeah, I don't know if 2 minutes is right. I'd have to time it. It definitely could be improved greatly. There's a lot of templates. Templates slow down the compile time a lot. And then also MSVC just is always kind of slow. The linking is really bad. I don't know how many lines of code we have now. That's actually an interesting question to ask. Let's see. Do I really have that much code? Oh, it's counting all this bind stuff. That's right. I forgot about that. That kind of sucks. I think spine is like, what if there's a good way for me to exclude the spine stuff? Because if we do, what is that? Go, include siege spine. Ah, there it was. Spine. That's 3,000 lines right there. And that's 9,000. So 12,000. I apparently don't have. So this is. We have the code I actually wrote is 13,000, but it is compiling 26k. But this is how much code we've written for projectDIG so far. The spine stuff is kind of like an external library, but it's been included. That's how they just set it up. Is clock.bat yours? Yeah. Well, it ends up, and I could probably improve it, but what the clock does, and that's count lines of code. It just runs the go clock. When will the next update or next bug fix be for Korea? Next month, I think. Well, probably, yeah. I think it will be October, sometime. Definitely this year. Absolutely, positively this year. I don't know if it's gonna be next month or November. So it's, yeah. Okay, so let's set up some stuff here. This is like my sandbox of just junk. So what we want to do is add in some particle stuff. I don't know if I have much here. Like, how can I do this? Channels, emitter, channels. What's our, okay. So this is our channels. This contains the emitter channel state. This is the key, right? So the key is supposed to be pointing to our emitter. So we're supposed to have this like database, and I guess we haven't done this yet. We need to have like a database of emitters. Yeah. I don't remember. Okay, we have done some of that in here, right? Yeah, here we go. Here's our database of emitters. It's not much of anything, but like we don't have a way to actually populate this right now. So let's see here. What is an emitter? An emitter is really just a set of channels. So much stuff. Do you need a debugger? And you mean like a tester? Not right now. Whenever we get closer to the release of the next update, we will probably be releasing like an alpha build, but yeah, not right now. I'll be posting on the Discord channel whenever we do need testers. By the way, just to let you guys know, I have probably like half an hour left of the stream before I need to go watch my daughter. So just a heads up. Okay, so what I'm thinking we can do is something like for now at least, we can do add emitter. And maybe what we could just do is maybe I'll do it like this. Emitter ref get emitter, and maybe I'll just like pass in the key. What do in the component? It's a uint32. Okay, we'll do that uint32t. We'll do it this way for now. Because I think I'll end up changing this anyways. So that way we can just get the emitter by reference, and then what we will do is go into the game here and we'll just say, okay, let's get our emitter. So we're going to create a new emitter, and so this is going to be for particle, get emitter, we'll just say 0. How many people are playing Korea? Will I be streaming after, or will that be it for the day? It's probably going to be it. I don't know. There's a slight possibility that my wife will be watching my daughter, and I might just have to go AFK for like a short while. We'll see. Yeah, sorry, I have like life has been busy since the newborn. It has been very busy. You can see how many people are playing Korea over here. Looks like someone streamed it. That's cool. So this blue graph is how many people played. So it's definitely slowing down right now, but it's doing okay. If you go back, oh, here we go. You can see there's a lot of people playing after or whenever we had that big sale. And then it definitely, you know, it obviously slowed down significantly. Yeah. Oh, working on the game, sorry. Working on Korea. I misread. Yeah, it's myself and Andrew right now. I need to learn how to read. We don't care about the name right now, so we'll add a new channel. Yeah. Probably just do like pushback. What is it called? Emitter channel? Can I just do in place back? That's it, right? Like it doesn't take any args, and then I can say channel is emitter channels back. Yeah. Okay. So now we can set up our... Man, we have to do so much stuff. Now we need to set up all of this. How long to emit particles for? Okay, so we'll just say, let's make it be a very long time. Int range. Oh, I need to make this be an int range. Okay. That's 50 seconds. Actually, you know what? 5 seconds is fine. What's wrong with this? Int range. I should be able to change that. It is the deleted function. Did I? Maybe I can't do it like this. I wonder if it's deleted because I have those be const. This is actually, I was trying to make it so that our range class is immutable, but maybe that doesn't work. Yeah, it seems by making those const, it means that I can't, like if I have, yeah, that's probably what it is. If I have any of the member variables const, then it deletes the copy constructor or the assignment constructor. What is immutable? Mutable means that it cannot be mutated or changed. So it is always the way it is as it is initialized. Immutable. Okay. So we need to just set more stuff in here. Let's go back to particle. The delay, that can be 0. That's okay. You know, we probably should, in this case, have it be initialized to 0. Or maybe what we can do... This probably ends up being the same. No. Yeah, we'll do it this way. I think we need that. Delay is fine. Frequency is going into range. Right now we don't have any randomness, so it's always going to be the same. What will be added or what will be fixed in the next update? We're going to be adding a bunch of new things dealing with chaos. And so we're not really talking about that too much yet. And we're also just fixing various issues. So I can't really say too much. It's kind of a secret. But you can expect somewhat more or less of the same of what we did for the previous update. Kind of following the same lines. Like with the chaos boss and whatnot. I don't know if you got that far. Frequency. Does this make it be every half second? Right now, this doesn't actually work. Because, I mean, we don't have any randomness, so. The amount. So it's always going to be right now the lower number. 35. Okay. And we do need to set up the texture, vertex shader, and fragment shaders. What that is going to be is a good question. Hey, Sound of Gaming. What's up? There'll be a gun. I wouldn't count on that. Guns don't really fit in the world of Korea. Yeah, sorry. Yeah, I don't think there'll be any new types of weapons in this next update. There might be new weapons, but not new types of weapons. I'm doing good. Thanks for asking. Sounds like fun working on the networking concepts. Yes, lots of fun. Trying to think. I do believe. Okay, yes. I set this stuff here. So we're just going to use the default shader. Okay, resource load. We just want this. That's for the. That's the vertex shader. Whoops. I guess we could just do this. All we need to change is that, right? FS. Okay. And then we need the texture itself. We probably set that up here in some place right now. Maybe not. A variant on the wand? That's an interesting idea. A wand gun. Parse. Okay. How goes the project today? It's going all right. Just trying to actually get particles rendering. Yeah, it's going good. We'll see for sure whenever we actually get something going. You know, for now we could just like have it do like a door or something. The particle could be a door. I think I'm okay with that. I think I'm trying to remember. I guess we probably just want to look at this. No. Yeah, I think it's just going to be data slash door dot png. And then we have the channel texture rec. Oh no, that's the particle. Oh. I guess that's a good point, is like, how do we know what the... Right now we'll just set this here as well, text direct. Which will be, I think it's 2424. And then we need to go over to here. Whenever we're setting up a particle, a new particle, you meant more particles. Here we go. Particle text direct. For now, we'll just set it to be whatever our emitter channel has. So that's channel, emitter channel, text direct.x. You know, actually, this would be a lot easier. Let's just do it like that. There we go. In the future, like what we might want to do is have it so that our channel supports maybe multiple text directs. And so we could say, hey, our particles for this emitter channel can be one of these 5 or whatever. I don't know what we want to do with that exactly, but maybe we will support multiple text directs or multiple, yeah, just like multiple different sprites for a channel. Maybe. Door. How was your day? My day's good. I'm over in California, so my day has just begun. 10:15 right now. But yeah, it's going all right. Woke up at like 7:30, took a shower, made some coffee, started streaming. That's my day so far. So it's going good. Actually getting some work done, which is nice. Okay, so we're just trying to populate this channel with a bunch of stuff. Okay, so we need to set up a lot of this. Details on how to set up and update the particles, the lifespan. So that's how long a particle lives for, lifespan. I don't know. I'm just kind of randomly setting this stuff. Distribution. Again, like all of this, we don't have any randomness, so it's all of our particles are actually going to end up being kind of the same. Like they're going to look the same. I do need to, I think maybe like tomorrow we'll just have to add in randomness. Distribution, we can leave that alone, I think. That should be fine. There's the speed delta. So we can just say the speed is, I don't know, 3. We don't need to add in the speed delta. We can say that the direction is equal to, let's just say 90. Actually, let's just leave it alone. We can say it's 0. Channel Scale is just 1. Yeah. Oh, that's a float range, huh? Whoops. How is that? Oh, I see. It's I wonder if I should make that be explicit then. I don't know. It's kind of nice, actually. I didn't realize that until this right now. So I can set the life. Actually, I do kind of like that. That's actually pretty cool. Because of, I wonder if I had that supported in Korean. I didn't realize it. Where's our range at? I guess I closed it. Range. So we have this constructor here, and this is implicitly casting the value to a range. In some ways, it's kind of nice. So like we have this here, the speed. We're just saying, hey, the speed is always 3. But we could also say, hey, this is a float range. Float range that is from like 3 to 4.5. And that would also work. But I like being able to just do that. Or you can just say, oh yeah, that's 3, that's 0, that's 1. Alright, so this will add in the emitter. And then, what do we need to do? I guess so I need a new... I need a new prefab that has... Do I need a new prefab? Maybe I should be using prefabs for this stuff. I'm like still trying to figure this all out. We need to create, like down here, whenever we press P, basically what I want to do is kind of like what I was doing over, where's that at? I guess it was here. World.create prefab stash get prefab ID. Yeah, so something almost like this. Our prefab ID is going to be our particle emitter. I don't even know if I need to do... Oh, I want to set... Okay, yeah, we want to do that. Reposition. World entity position. What's this reposition? Oh, it calls that script. I forgot about that stuff. Okay. Yeah, oh, whoops. So we get the transform for that entity, and then what we want to do is set the bounds, right? Bounds.x and bounds.y. Bounds.x to be this stuff. I guess I can just copy that. So what this is doing is saying, create this new entity at this position at the mouse. Actually, event.button is not quite right. We want to get the mouse button position. Where is that at? There we go. Get mouse state. We'll do that up here for right now. Okay. So the last thing we need to do with that is now set up our prefab ID. which will be our particle prefab. And we'll set that up over here, I guess. What do we get? Oh, there we go. Prefab stash. Oh, I think it looks like we just have it already. Prefab stash get. We get it by name. Okay, yeah. So we could just say like door particle. Particle prefab. And we just pass that in, right? That's pretty cool. I mean, technically we could just do that here. There we go. That's cool. So we have our prefab stash. We say, hey, get the door particle and create a new entity and set the position to be here. And so then what we need to do is go make a new door particle thing. Door particle prefab. One thing we need to do with that though, let's not use that. Let's go to, here we go. Door particle. No wait, that's Korea. Is this? Yeah, here we are. This right now is saying it's an item. I don't remember what an item is. We haven't messed with this stuff for a while. So here's an item. We do a knit and then collision. Man, I can't wait to get to this stuff. It's going to be so awesome to start actually using these systems. I kind of forgot how we were setting this up. Can you make it as the projectile travels, it increases size or decrease, and at the end of the travel it expands and creates an explosion? Are you talking about for wands? I think there's a wand that is like that, right? Something like that. I'm trying to remember how we do our prefabs, to be honest. Okay, so I think what we'll end up doing for now is to say like, let's name can be door particle. I was talking about wands. I feel like there is a wand that does that. I don't know. That'd be a cool, what is it called? Attribute? You know, like you have piercing or, there are other ones. I'm not thinking of them right now. I know arrows have like bouncing. I don't know if wand projectiles can bounce. I don't think so. But like having one that can be explosive would be cool. I don't know. Think about it. It's an idea. I've worked on Korea a little bit recently, but I haven't for a few days or like I've actually for like the last 2 weeks I think I've only done like a little bit of work. I've been busy. So I'm not exactly in the mindset of Korea stuff right now. Prefab is where we need to go. So this is where all of our prefab stuff is happening. So what I need to do is add in a new thing in here, which is to say that it has particles, right? This has 2. Oh, whoops. Maybe I'll call it emitter, soul, table, data. I haven't messed with this for a while, so I'm trying to remember exactly. Like, it's been like 3 months since I touched this. I think what I just want to do is something kind of like this. So it'd be like particle. Wait. Let's go to component. So we have the particle component and we have the emitter component. I think we just want something like this. So we'll say particle component, particle equals prefab, add particle component. That adds it, particle, and then we just set the key. Right? Data get bound. So I think in the future, what we'd want to do is base it off of the name. I think. I don't know. For now, we'll just say 0. I know this is not right, but I'm just like trying to hack it in so that way we can actually see something. I might need to go though in just a moment. Let me check. Oh wait, I got a message from Kelly. Yeah, give me. All right, let me. Yeah, 1 second. Yeah. What was that called again? Emitter. Unfortunately, I'm not going to be able to finish this today. We'll have to pick it up tomorrow. I have to go watch my daughter. My sitter is leaving here in just a minute, and so I need to wrap this up. Sorry, guys. Thank you for joining, though. I will be back hopefully tomorrow. Yeah, hopefully tomorrow. So thank you for joining. I appreciate it. I hope that you guys have a good rest of your day. And if you're not following already, feel free to follow and you can be notified whenever I do go live. Sorry, my schedule is kind of all over the place. But yeah, have a good one and I'll see you guys next time. Take care.